Good evening, children. Once again, welcome to One Mark Solution. Please like, share, and subscribe to your friends. Let us move on to the case study, third one, from the chapter Light Reflection and Refraction of Physics. Now, we are going for the case study. You can see that. Yes. The relation between the distance of the object from the lens u. The distance between object and the lens, we can take it as u. The distance of the image from the lens, you can take it as v. And the focal length, f. Focal length also, we know that. The distance between the focus and the lens. Focal length of the lens is called lens formula. It can be written as 1 by f is equal to 1 by v minus 1 by u. You know the relation u, v, and f. That is a lens formula. We can call it as lens formula. Similarly, you are studying in mirror formula. What is the difference here? Means here the u is taken as minus. That means 1 by u, before that minus is there. You should be very careful. Don't get confused between the mirror formula and the lens formula. The size of the image formed by lens depends on the position of the object from the lens. A lens of short focal length has more power, whereas a lens of long focal length has less power. When the lens is convex, the power is positive, not only power positive, focal length also is positive. And for concave lens, the power is negative. Of course, concave lens, we can say focal length also is negative. Power means it is a reciprocal of lens. Sorry, reciprocal of focal length. Focal length means we have to take focal length in meter. So 1 by f in meter, we can say power. The unit of power is diopter. That also you have to note it. The magnification produced by a lens. What is the magnification? How much large the image you are seeing and how much diminished, that is magnification. So how will you find the magnification? We can say it is the ratio of height of the image to the height of the object. That means how much it is enlarged or how much it is diminished. Hi by ho or h dash by h, we can say that. So height of the object and the height of the image. So hi by ho. As the size of the image related to the object is given by the linear magnification. Linear magnification, why we have specified like this? Why? Because in telescope and all, we are studying angular magnification. You are not going to study, you are studying only the basic thing, that is a linear magnification. Now we can say when m is negative, that means if magnification you are getting negative, we can say image formed will be real. That also you can note this point. That means whenever the image is real, you can say magnification is negative. The reverse also you will get it. Okay. Then image formed is virtual. When the image formed is virtual, then m will be positive or reverse. If magnification is positive value, the image will be sure virtual. And you know the difference between real and virtual. Now we can say that if m is less than 1, that means the value of m is very less. Size of the image will be smaller than the object. That means diminished image, you will get it. Diminished one. If m is greater than 1, the size of the image will be larger than the object. So you can note all these points. Just a minute. Here you can say what all things you have to study. Here lens formula you have to note it. And the negative sign also you have to note it. Next one we can say the power. Of course, including focal length also you should know. Convex, focal length positive, power positive. Then concave, focal length negative, power negative. And the next one is magnification. Magnification, if it is negative, we can say real. If it is positive, we can say virtual. If m is less than 1, that means very less. Size of the image will be less, diminished. If m is greater than 1, we can say size of the image will be larger than the object. That means it is enlarged. Now let us move on to the question number 1. You can see that an object 4 centimeter in height is placed at a distance of 10 centimeter from a convex lens of focal length 20. the position of the image you have to find. You know the equation. I have just written here, but we have studied there. 1 by f is equal to 1 by v minus 1 by u. 1 by f is equal to 1 by v minus 1 by u. Just now we have studied the length formula. You can just substitute in this equation and you can find it. Very simple, you can do it. Why? Because, but here you have to what is that? You have to, yes, find the sign convention. You have to use here sign convention. You have to take it as negative. Why? Because you know that always you have to take optic center. Where is object? Object, it is placed here and the lens is here. We are taking from optic center. So light is coming from here, it is positive. But if you are taking from here, it is negative. If it is lens and this is the image, if you are taking this distance, it will be positive. So you have to take it as negative. So here already minus when it is coming to this side. So what will be the answer here? 1 by 20 minus 1 by 10. 1 by 20 minus 1 by 10, you will be getting the answer. Either you go for LCM and all, or you can say 1 by 20 minus 2 by 20. So what will be the answer here? We are getting the answer. The focal length, if you are just simplifying, you will get minus 20 centimeter. Very simply, you can do it. Minus 20 centimeter. You will get minus 1 by 20 as 1 by f. And f, the reciprocal f, you will get it. What is it? Minus 20 centimeter. So that is option D. Now let us move on to the second one. In the above question, the size of the image, that means in the above question, means the first question, it is written as object is 4 centimeter height. So we can say HO is 4 centimeter. Then we can find the magnification using this formula. Which formula? V by U. We can use magnification by V by U. So if you are using magnification, we can say, here I have written here, M is equal to V by U. What is V here? Minus 20. We got it now, minus 20 V. And minus 10 U. What will be the answer? The magnification is 2 centimeter. Magnification is 2. That means the ratio will be 2. Now, if you want to get the height of the image, height of the object they have given, HI by HO. Instead of HO, I have written here O. What is it? 4. Instead of HO, I have written here 4. That means H by 4, we are getting 2. So what is H here? That means H is here. It is height of the image. You are getting the answer 8. So the answer will be 8 centimeter. Now you are getting the answer 8 centimeter. Very simple. The equation you have to study for magnification. Two equations you have to study, HI by HO and V by U. And see, the sign convention is very, very, very important when you are applying the equation also. Now we can go for the third question. Third question, we can say an object is placed 50 centimeter from a concave lens and produces a virtual image at a distance of 10 centimeter in front of the lens. The focal length of the lens, the same lens formula, you can use it here. 1 by f is equal to 1 by v minus 1 by u. But you have to think that if you are getting the answer positive, then your answer is not correct. Okay. So here, what is v? What is v here? 10 centimeter. What is u here? 50 centimeter. You can just apply the formula. You will be getting the answer. If the answer is positive, that is not correct. The answer should be negative. So the answer will be minus 12.5 centimeter. If you are simplifying, it's very simple. You will get the answer is B, minus 12.5 centimeter. Now let us move on to the fourth question. A concave lens of focal length 5 centimeter, the power of the lens you have to find. You know that focal length of the concave is negative. So sure, power is also negative. You can see that what is the equation for the power? 1 by f. That means the reciprocal of the focal length. But f you have to take in meter. You can see that I have taken f in meter. Okay, if you're taking f in meter, if it is given as centimeter, centimeter when you are converting in meter, how will you get it? Into 10 raised to minus 2. That means when it go up, it is 100. 10 raised to 2, it is 100. So can we write like this? P is equal to 100 by f. If you are studying this also is good. Only thing you have to see that if you are writing f in meter, then only you have to use this. And what is the unit of power? It is written there, diopter. The first letter we are using here, you can see DDD you have written here. So that is diopter. So what is power and what is the unit of power is also equally important. And here if you are doing this, what is it? Focal length is given with this formula. If you are just calculating what you will get 100 by 5. 100 by 5 is 20. So the answer is 20. But again, you have to see that whether it is minus or plus. So the answer is minus 20D. That is the correct answer. So option D. Let us move on to the next question. Lens formula. That is very simple. The lens formula, we can say that 1 by f is equal to 1 pi v minus 1 pi u. It is not there. It is wrong actually. Fifth. By mistake, it has come up. So 1 by f is equal to 1 pi v minus 1 pi. That is the correct answer. Thank you. You can see the correct answer. It is written there. 1 pi f is equal to 1 pi v minus 1 pi. Thank you for watching. Thank you.